Chapter 1. Power of Blockchain Technology. Unlocking the Potential. Exploring the versatility of blockchain technology. A blockchain functions as a distributed database or ledger shared among a network of computers. Its primary purpose lies in maintaining a secure and decentralized record of transactions. While commonly associated with cryptocurrencies, such as Bitcoin, blockchain technology extends beyond just financial uses. Its versatility enables it to ensure data is unchangeable across various industries. The fundamental characteristic of a blockchain is its inability to alter data once it's recorded within a block. This immutability eliminates the need for reliance on trusted third parties like auditors, reducing costs and potential errors. Trust is mainly required during data input, as the integrity of the blockchain ensures the permanence and accuracy of recorded information. The increase of blockchain applications has expanded rapidly since the inception of Bitcoin in 2009. Its utilization spans across decentralized finance, DeFi, platforms, non-fungible tokens, NFTs, smart contracts, and other innovative ventures. These diverse applications demonstrate the adaptability and potential of blockchain technology beyond its original purpose. Understanding cryptography. Cryptography is the practice of securing information by converting it into a form that only authorized individuals can understand. This process involves using mathematical techniques to transform original data, plaintext, into a scrambled format, ciphertext. The goal is to make it extremely difficult for unauthorized parties to decode the information without the correct key. Cryptographic techniques ensure that sensitive information remains confidential and protected from unauthorized access. It involves encrypting data to make it unreadable to anyone without the decryption key. This encryption process is crucial for maintaining privacy and security in various applications, such as secure communication and data storage. In simple terms, cryptography is like locking a message in a box before sending it. Only the intended recipient with the right key can open the box and read the message inside. This method safeguards information from prying eyes and potential threats, making it an essential aspect of modern digital security. The structure and security of blockchain technology. In contrast to traditional databases or spreadsheets, a blockchain's structure and accessibility set it apart. Information is stored in blocks linked together through cryptographic mechanisms. This distributed nature ensures redundancy, with multiple copies stored on various machines. Validity is maintained through consensus among these distributed copies. A blockchain operates by collecting transactional data and organizing it into blocks, akin to cells in a spreadsheet. Once a block reaches its capacity, the data undergoes encryption, generating a unique hash, a hexadecimal identifier. This hash is then incorporated into the subsequent block, forming a chain of interconnected blocks. The encryption process ensures the security and integrity of the data within each block. This chain of blocks, secured through cryptographic mechanisms, establishes the immutability and transparency characteristic of blockchain technology. Consequently, transactions recorded on a blockchain, such as those within the Bitcoin network, become permanently accessible to all participants. The decentralized nature of blockchain networks ensures that control is not vested in any single entity or group. Instead, users collectively maintain control, fostering trust and transparency within the network. This decentralized governance model underpins the resilience and reliability of blockchain technology, facilitating its widespread adoption and innovation across various sectors. Blockchain technology revolutionizes data management by providing a secure, transparent, and decentralized framework for recording transactions and storing information. Its applications extend far beyond cryptocurrency, offering solutions to various challenges across industries. As the technology continues to evolve, its impact on economies, governance, and society as a whole is poised to expand further. Blockchain transaction processes compared. The transaction process within a blockchain varies depending on the specific blockchain network in question. Taking Bitcoin's blockchain as an example, initiating a transaction through a cryptocurrency wallet sets off a series of steps. Initially, the transaction is submitted to a memory pool, where it awaits validation by a miner or validator. As transactions accumulate in the memory pool, they form a queue until they are included in a block. Once a block is filled with transactions, it undergoes encryption using a cryptographic algorithm before the mining process commences. Miners across the network simultaneously compete to solve a cryptographic puzzle by generating a valid hash. This involves appending a nonce, or a number used once, to a randomly generated hash until a hash meeting specific criteria, known as the target hash, is found. This process, known as proof of work, demonstrates that the miner has invested computational resources to validate the block. The validation process in Bitcoin involves confirming the block, which includes the transaction, through a consensus mechanism. However, a transaction is not considered fully confirmed until it has been included in 5 subsequent blocks. Given that Bitcoin's network aims for an average block generation time of approximately 10 minutes, achieving confirmation typically takes about an hour. It's important to note that not all blockchain networks employ the same transaction process as Bitcoin. For instance, Ethereum, another prominent blockchain network, utilizes a different consensus mechanism known as proof of stake. In this model, a validator is randomly selected from all users who have staked their cryptocurrency, Ether, to validate blocks. This approach is not only faster but also consumes less energy compared to Bitcoin's proof-of-work mechanism. The contrasting transaction processes among blockchain networks highlight the diversity in approaches to achieving consensus and validating transactions. While some prioritize security and decentralization, others prioritize efficiency and scalability. These differences contribute to the unique characteristics and functionalities of each blockchain network, catering to diverse use cases and preferences within the broader blockchain ecosystem. Blockchain decentralization. Blockchain decentralization ensures that the data stored within a database is distributed across multiple network nodes, which are computers or devices running blockchain software. This distribution not only enhances redundancy but also safeguards the integrity of the data. In the event of an attempt to alter a record within one instance of the database, the presence of other nodes prevents such alterations, ensuring the immutability of the information. This decentralized architecture prevents any single node from unilaterally modifying the data it holds. The distributed nature of blockchain, coupled with the cryptographic proof of work, ensures the irreversibility of information and transaction history. While commonly associated with cryptocurrency transactions, blockchains can store a wide range of data, including legal contracts, state identifications, or inventory records for companies. This versatility underscores the applicability of blockchain technology across various industries beyond just finance. Blockchain transparency. Blockchain transparency is a key feature facilitated by its decentralized architecture. In the case of Bitcoin's blockchain, all transactions are transparently recorded and can be viewed either through personal nodes or blockchain explorers. Each node maintains its copy of the blockchain, updating it as new blocks are confirmed and added. Consequently, individuals have the ability to track the movement of cryptocurrencies in real time, enhancing transparency within the network. An illustrative example of blockchain transparency is evident in cases of cryptocurrency exchange hacks. Despite the anonymity often associated with cryptocurrency transactions, the public nature of blockchain allows for the traceability of stolen funds. Wallet addresses associated with hacked exchanges are published on the blockchain, enabling individuals to monitor the movement of funds, even if the perpetrators attempt to remain anonymous. It's important to note that while blockchain records are transparent, they are also encrypted, ensuring the privacy and anonymity of users. Only individuals with access to the private keys associated with their addresses can reveal their identities. This cryptographic feature enables blockchain users to maintain anonymity while simultaneously benefiting from the transparency and immutability of the technology. How blockchains are used. Blockchains find applications beyond cryptocurrency transactions, serving as a reliable means of storing various types of transactional data. While Bitcoin's blockchain is renowned for recording financial transactions, over 23 000 other cryptocurrency systems operate on blockchains. Additionally, companies across industries are exploring the potential of blockchain technology for diverse use cases. Major corporations like Walmart, Pfizer, AIG, Siemens, and Unilever are among those experimenting with blockchain technology. For instance, IBM has developed its Food Trust blockchain to trace the journey of food products from their origins to their final destinations. This initiative addresses challenges within the food industry, such as outbreaks of foodborne illnesses like E. coli, Salmonella, and Listeria, often resulting from contaminated products or hazardous materials inadvertently introduced during processing. Traditionally, identifying the source of foodborne outbreaks or determining the cause of illnesses linked to food consumption has been a time-consuming process, taking weeks or even months. By leveraging blockchain technology, companies can track the entire journey of a food product, including every stop it makes and its interactions along the way. This comprehensive visibility enables swift identification of potential issues, significantly reducing the time required to pinpoint the source of contamination and take corrective measures. The implementation of blockchain in the food industry exemplifies how the technology enhances transparency and accountability while improving safety and consumer trust. By enabling real-time tracking of food products and their associated data, blockchain empowers companies to proactively manage risks and mitigate the impact of foodborne illnesses. Moreover, the ability to trace products throughout the supply chain facilitates rapid response and containment efforts in the event of contamination incidents, potentially saving lives. Beyond the food industry, blockchain technology offers myriad possibilities for streamlining processes, enhancing security, and fostering trust in various sectors, from supply chain management to healthcare, finance, and beyond. Blockchain's decentralized and immutable nature provides a robust foundation for innovation and transformation. As companies continue to explore and adopt blockchain solutions, the technology's potential to revolutionize diverse industries becomes increasingly evident, paving the way for a more transparent, efficient, and secure future. Banking and finance. The integration of blockchain technology into banking and finance has the potential to revolutionize traditional business operations. Unlike financial institutions that operate within set business hours and require time for transaction verification and settlement, blockchain operates continuously, without interruption. This means that transactions processed on a blockchain can be completed within minutes or seconds, regardless of the time of day or week, offering consumers unprecedented speed and convenience. By leveraging blockchain, banks can significantly reduce the time and resources required to settle transactions, leading to enhanced efficiency and cost savings. Additionally, blockchain enables secure and swift exchange of funds between institutions, minimizing the risks and costs associated with traditional banking processes. This real-time settlement capability represents a significant advancement in the financial industry, providing greater flexibility and agility in managing funds. One area where blockchain can particularly streamline operations is in the settlement and clearing process for stock traders. Traditionally, this process can take up to 3 days, or even longer for international transactions, during which time both money and shares are effectively frozen. With blockchain, this time frame could be drastically reduced, allowing for faster and more fluid trading activities. This not only improves liquidity but also reduces counterparty risks and enhances overall market efficiency. Currency. Blockchain technology serves as the foundation for cryptocurrencies like Bitcoin, offering a decentralized alternative to traditional centralized currencies controlled by institutions like the Federal Reserve. Under the current central authority system, users' data and currency are subject to the control of banks or governments, exposing them to various risks. For instance, if a user's bank is compromised by a cyber attack, their private information becomes vulnerable to exploitation. Individuals living in countries with unstable governments or volatile currencies face the risk of currency devaluation or financial instability. The financial crisis of 2008, during which failing banks were bailed out using taxpayer funds, highlighted the vulnerabilities inherent in centralized financial systems. Bitcoin emerged as a response to such concerns, offering a decentralized currency immune to government manipulation or bank failures. By leveraging blockchain technology, cryptocurrencies provide individuals in unbalanced regions with access to a more stable financial system and currency. Through decentralized networks and distributed ledger technology, cryptocurrencies offer a secure and transparent means of conducting domestic and international transactions, without the need for intermediaries or centralized authorities. Healthcare. In the scope of healthcare, blockchain technology holds significant promise for securely storing and managing patients' medical records. By leveraging blockchain, healthcare providers can ensure the integrity and immutability of medical records, providing patients with confidence in the accuracy and privacy of their health information. When a medical record is created and digitally signed, it can be written into the blockchain, establishing a tamper-proof record that cannot be altered or tampered with. These personal health records are encoded and stored on the blockchain using private keys, ensuring that only authorized individuals have access to them. This cryptographic approach to data storage enhances privacy and confidentiality, as sensitive medical information remains securely encrypted and accessible only to those with the appropriate permissions. This not only protects patients' privacy but also safeguards against unauthorized access and potential data breaches. Moreover, blockchain technology offers healthcare providers and patients alike with greater transparency and accountability in managing medical records. The decentralized nature of blockchain ensures that medical records are distributed across multiple nodes in the network, reducing the risk of a single point of failure or data loss. This redundancy enhances the reliability and availability of medical records, even in the event of system failures or cyberattacks. Property rights. The traditional process of recording property rights at local recorders' offices is known to be burdensome and inefficient. It involves physically delivering a deed to a government employee, who manually enters it into the county's central database and public index. This manual process not only incurs costs and consumes time but also introduces the potential for human errors, which can undermine the accuracy of property ownership records. In cases of property disputes, reconciling claims with the public index further complicates the process. Blockchain technology offers a solution to these challenges by digitizing and decentralizing property records. By storing property ownership information on a blockchain, the need for physical documents and manual data entry is eliminated. Property owners can have confidence that their deeds are accurately recorded and permanently stored on the blockchain, reducing the risk of errors and discrepancies in property ownership records. Blockchain provides transparency and immutability to property ownership records. Each transaction recorded on the blockchain is cryptographically secured and cannot be altered or tampered with, ensuring the integrity of property records. This transparent and tamper-proof nature of blockchain enhances trust and confidence in property ownership information, benefiting both property owners and stakeholders in real estate transactions. In regions with limited government or financial infrastructure, proving property ownership can be a significant challenge. Blockchain technology offers a decentralized solution that enables transparent and clear timelines of property ownership to be established. By leveraging blockchain, individuals in war-torn or underdeveloped areas can securely record and verify property ownership, reducing disputes and facilitating economic development. Supply chain. In supply chains, blockchain technology offers a transparent and secure way to track the origins of materials purchased by suppliers. By recording this information on a blockchain, companies can verify the authenticity of their products and validate labels such as organic, local, and fair trade. This ensures greater transparency and trust throughout the supply chain, enabling consumers to make informed decisions about the products they purchase. The adoption of blockchain in the food industry, as exemplified by initiatives like IBM Food Trust, is gaining momentum. Blockchain enables food producers and suppliers to track the path and safety of food products from farm to consumer. This technology enhances traceability and accountability in the food supply chain, helping to prevent foodborne illnesses and ensuring compliance with regulatory standards. As reported by Forbes, The use of blockchain in the food industry is increasing as companies recognize the benefits of enhanced transparency and traceability. By leveraging blockchain technology, food producers can improve food safety, reduce fraud, and build consumer trust. This adoption of blockchain in the food supply chain underscores its potential to revolutionize how goods are tracked and verified throughout the supply chain process. Furthermore, blockchain can streamline property transactions by automating processes such as title transfers and mortgage registrations. Smart contracts. Self-executing contracts with the terms of the agreement directly written into code can automate the execution of property transactions once predetermined conditions are met. This automation reduces the need for intermediaries and paperwork, making property transactions more efficient and cost-effective. Voting. Blockchain technology holds promise for revolutionizing the voting process by offering a modern voting system that enhances security and transparency. A notable example of blockchain-based voting was tested during the November 2018 midterm elections in West Virginia. Utilizing blockchain for voting has the potential to significantly reduce election fraud and increase voter turnout. The inherent security features of blockchain make it extremely difficult to tamper with votes once they are recorded. By leveraging blockchain protocols, voting systems can ensure the integrity and immutability of election data, providing a secure platform for casting and recording votes. This enhances confidence in the electoral process and reduces the risk of fraudulent activities compromising election outcomes. Furthermore, blockchain-based voting systems offer transparency throughout the electoral process. The decentralized nature of blockchain ensures that election data is publicly accessible and verifiable by all stakeholders. This transparency reduces the need for extensive manual oversight and verification processes, streamlining the election administration and providing officials with nearly instant results. Adopting blockchain for voting can also enhance efficiency by reducing the personnel required to conduct elections. With blockchain-based voting systems, the need for paper ballots, manual vote counting, and physical polling stations is minimized. This not only saves time and resources but also eliminates the need for recounts or concerns regarding the integrity of election results. Overall, blockchain technology holds immense potential to transform the voting process by offering a secure, transparent, and efficient platform for casting and recording votes. By leveraging blockchain, elections can be conducted with greater integrity, accuracy, and accessibility, ensuring that every vote counts in the democratic process. Blockchain education for all. Innovative approaches to education, such as community-led initiatives, online courses, and open access platforms, can empower individuals to learn about blockchain independently and collaboratively. By democratizing access to information and resources, these initiatives can level the playing field and ensure that everyone has the opportunity to benefit from blockchain technology. Moreover, fostering a culture of collaboration and knowledge sharing can help overcome barriers to adoption and promote inclusivity in the blockchain community.